This is going on page 70 when we are done. So we are graphing logarithmic functions. We graphed exponentials. We've looked at some exponentials and logs. We're going to graph logs. We're going to go back and do some more stuff with logs. All right, so our logarithmic function, where b is the base, we would have f of x equals log base b of x. Okay. So in order to have a parent function to refer to, we have to have a number for b. So usually we will use 10, so a common log, either that or 2. It kind of depends whether or not you're comparing these. Sometimes we'll use log base 2 because we use 2 to the x here. But so a logarithmic function is the inverse of an exponential function. So it says using your graphing calculator. Obviously we're not doing that. We don't need to use a calculator at all. You need to be able to do this without a calculator. You need to take those words out. So let's graph the exponential first because we already know how to do those. Well, you should know how to do the others too. But for the exponential here, do I have an asymptote? Yes. Where is it? Y equals 0. Good. So your asymptote is right here. Then for any parent function, whether this is the base is 10, 2, 5 million, whatever, what's your y-intercept? 1, because when x is 0, y is 1. It doesn't really matter what that base is, right? And then when we draw in the function, it looks something like this, right? So if a log is the inverse, then that means graphically it gets reflected in the line y equals x. So if we take that asymptote that's at y equals 0 and it gets reflected in the line y equals x, where does it end up? What would my asymptote be on a log if it got because this is if this gets reflected in the line y equals x, where does it have to end up? Well, it's a line, so the asymptote, this line right here, gets reflected in the line y equals x. Where does this line end up? X equals 0, exactly. Okay. All of the y-intercepts, I guess. An infinite amount of y-intercepts. Y-axis is what you meant. Okay. That makes more sense. All right. And then that point that we have over there that's at 0, 1, when we do the inverse, where does that point end up? 1, 0. Oops. It ends up at 1, 0 right here. Right? Because when you do a log, anytime you have an x value of 1, then your y value is going to be 0. So then when you draw this in, this is what your log function looks like. It's a reflection in the line y equals x of this function right here. So if I was to find the inverse of this and thinking that this is y equals 10 to the x, that means I would get x equals what? What would I get? 10 to the y. Yes, that's how we do an inverse. Okay, y'all with me here? Okay, because when you just take the inverse, this is the inverse of this right here. Okay, you switch x and y. Now, I'm not going to take the inverse of this. I'm just going to take this and write this in exponential form. So my base here is 10. My exponent would be y, and that would be equal to x. So you notice how you get the same thing here, whether you're finding the inverse or just rewriting this in exponential form. And then these two things, this is the same function, just written 2 different ways. These two are inverses of each other. So make sure you understand the difference between finding the inverse and just writing it in exponential form. It's just when you write it in exponential form doesn't mean you're finding the inverse, right? We good? All right. So to graph logarithmic functions, you can use the inverse exponential function, then invert. So that's basically what we're going to do to get all of our parent functions. Now, numbers 1 and 2 are both parent functions because there's no transformations happening. They just have different bases because that can vary with our parent functions, okay? So what we're going to do for all of these is we're going to take this and we're going to rewrite it in exponential form. So my base is 3. I would take 3 to the y power and set that equal to x, okay? So for the parent function, usually we know like where some points are, and we can, okay, when x is this, what is y, and so forth. But do you want to substitute in x for either one of these? No, because that's not something that you just know or can figure out in your head. So instead, if we chose values for y, would it be easier to figure things out? So instead of choosing values for x, we're going to choose values for y. And so for this first time, I'm going to write down a little t-chart, but we're not necessarily going to write it down every single time. So instead of choosing for x, I'm choosing for y. I'm going to choose -1, 0, and 1. When y is -1, what is x? 1/3. When y is 0, what is x? 1. And when y is 1, x is 3. Okay? And that should be something that you won't necessarily need to write down, but because it's backwards, because you're used to finding x and choosing x and finding y, sometimes you can think about it backwards. But those are my ordered pairs that I'm going to plot. Now, this is a logarithmic function. I have 0 transformations. So where is my asymptote? Where's the asymptote for a log function? Yes, and what's that line? X equals 0. Okay, so I'm here. It hasn't moved because there's no transformations. What is the only kind of transformation that's going to affect where my asymptote is? Well, I can shift up and down all day long. I can reflect all day long. I'm good. Left, right. Any translation left or right, that's going to move my asymptote. All the rest of it doesn't affect it. Okay? All right, so then here are my points. I have my x value is 1/3. My y value is 1. I'm sorry, it's -1. Oh, dang it. My x value is 1/3. My y value is -1. I can't even read what I wrote. X is 1, y is 0. X is 3, y is 1. Because log base 3 of 3 is 1, right? This is what your function looks like. Now let me show you how to think through this without having to even write that stuff down. Right? Instead, you think about it this way. Say, okay, when y, instead of thinking about what is happening with x, when y is -1, what is x? It's 1/3. Boom, there's your point. When y is 0, what is x? It's 1. When y is 1, what is x? It's 3. So you're just basically plotting the points backwards so that you can think about it backwards. Okay? We good with that? All right, so what's our domain? 0 to infinity. Good. Do I include 0? No. What's my range? -infinity to infinity. Good. What's my x-intercept? 1, 0. And if there's no transformations, it will always be 1, 0. Just like for an exponential, it's always 0, 1. My asymptote is x equals 0. Is this increasing or decreasing? Increasing. So it's increasing from where to where? 0 to infinity. And that means it's not decreasing at all. As x approaches infinity, what does f of x approach? Infinity. As x approaches -infinity. Now, does x approach -infinity? No, it doesn't. So I can't answer that. So there's a none. Can't even answer it. Okay. Yeah, NA is good too. All right, everybody okay with that? So let's do number 2, but without writing down the little T table and see if we can reason our way through this. So I'm going to rewrite this as an exponential. My base is 1/2. The exponent would be y, and I set that equal to x. Remember, I'm not finding the inverse. I am just rewriting it as an exponential. Now, there are no transformations left or right, which means my asymptote is still right here. Then you do the same parent function type of thought process that we've done for everything. But this time we're asking about y. So when y is -1, what is x? 2. So I go to 2, -1. When y is 0, what is x? 1. When y is 1, what is x? 1/2. Okay? And just make sure that you're not getting yourself mixed up with the x's and y's. And then this is what your graph looks like. So my domain, again, is from 0 to infinity. My range, again, -infinity to infinity. My x-intercept, again, 1, 0, because I haven't transformed anything. Asymptote, x equals 0. Am I increasing or decreasing? Decreasing. So this is none, and this is from 0 to infinity. As x approaches infinity, what does f of x approach? -infinity. And does x approach -infinity? Nope. This is none. We good? Any questions? All right, so that's just the parent function. So now we got to do this with transformations. So flip it over. What's the question? How do you know there's an asymptote? Because can you take the log of a 0? No, we don't need to check in the calculator. You need to be able to reason through it without a calculator. You need to be able to think. So can I find the log of 0? If I did, that means x would have to be 0, right? Like if I could substitute in a 0. Well, is there a power you can take 1/2 to get 0 out? Nope. No matter what that base is, there's not a power you can take to it to get 0 out. Y can equal 0. It's x that can't equal 0. I can't have an x value of 0. And I can't substitute in a negative number. There's no power I can take 1/2 to get a negative number out. I do. Oh, I don't have that much though, do I? I have some over here. Looks like somebody already emptied it for me. You can empty this. Thank you. Mm-hmm. Uh-huh. Do I? Oh, I do recycle. I don't know why that's empty. It's weird. All right. So does that answer your question? We good? All right. So now let's look at number 3. I'm going to rewrite this in exponential form. Now this is just a parent function as well because there's no transformation. So I'm going to rewrite this as an exponential. What's the base? E. So I'm going to take e to the y power equals x. Okay. Thank you. You can just stick it behind my desk. All right, so since it's a log function, it is a natural log, but it doesn't matter, right? Same properties. Where's my asymptote? X equals 0. Like it hasn't moved, right? Still here at x equals 0. Then I do the exact same stuff I do for graphing any of the parent functions. Okay, so I take -1. When y is -1, what is x? 0.36. Very good. Yep, that's a number you have to know. We don't have time to discuss it. Already been there. All right, so when y is 0, what is x? 1. When y is 1, what is x? 2.7. 2.7. There we go. And then this is what your function is going to look like. All right. Ooh, goodness. No. When y is -1, what is x? Right? So for every single one of them, I'm using -1, 0, and 1 for y. And if you need to write out a little table for yourself so you don't get them backwards, whatever. Just know that we are not substituting numbers into things that look like this to spit numbers out that are going to be all yucky. That is not the purpose of any of that, okay? So let's move on to number 4. Now we have some transformations. Even still, we are going to write the exponential version of the parent function. So just for this first time, I'm going to write what the parent function is of this. This parent function would be f of x equals log base 1/3 of x. Like it wouldn't include the +1. It doesn't include the transformations at all. So just the parent function is going to be rewritten as an exponential. And so that's going to give me 1/3 to the y power equals x. Then what kind of transformations do I have going on? Up 1, okay, and that's it, right? So since all I'm doing is I'm moving it up 1, does that affect where my asymptote is? No, so I'm going to get that drawn in first. Right. Okay, so then I work from my parent function. For the parent function, when y is -1, what is x? 3. 1, 2, 3. Then I do my transformations. I go up 1. Boom, I'm right there. Yeah, still got to do the transformation. So when y is 0, what is x? 1. And then I go up 1. When y is 1, what is x? 1/3. And then I go up 1. Okay. Now, if my x value, although I totally plotted that on the wrong, did I plot that in the wrong place? Oh, no, I didn't. Okay. I thought I did for a minute there. When you do these on your assignment, you're going to have to fill in the little chart like we did on the front. I just didn't think we needed to do it every single time. One thing you want to ask yourself before you draw this in is, do you know the x-intercept? Because first of all, it's going to be something they ask you. Second of all, if it's not already on there, you want to plot it before you draw it in. Otherwise, you may not actually hit it with your graph, and then you'll have to erase and do it again. You don't want to do that. So it should look something like this. Everybody okay with that? All right, so now let's look at number 5. I'm just going to rewrite the parent function as an exponential. So the base is 2. I would take that to the y power. That would equal x. Then I look at my transformations. That negative means that I would reflect in what? In the x-axis. Right? And then this 2 means I do what? Right 2. Okay. So, does my asymptote get affected here? Yes, I move to the right 2, so the asymptote has to move to the right 2. So I'm going to put that in there. Okay. So then I start with my anchor points from my parent function. For the parent function, when y is negative 1, what is x? 1/2. Then I reflect in the x-axis, right here, and I move to the right 2. So I end up with it right there. Okay? Then when y is 0, x is 1, I reflect in the x-axis, which means I go nowhere, and then I move to the right 2. When y is 1, x is 2, I reflect in the x-axis, and then I move to the right 2. I end up right there. So I have my 3 anchor points, one of which is the x-intercept, so I'm good to go ahead and draw it in. And there you go. Yes, exactly. And that's what we're going to do that on the next one, so yes. Because maybe it's something you can graph, maybe it's way off the graph, we don't worry about it, but okay. We all good so far? All right, let's do number 6. So my parent function as an exponential would be 4 to the y power equals x. There's no reflection. The 5 means I do what? Left 5 and then down 2. Good. And so does my asymptote get affected? Yes. So I'm going to go to the left. 1, 2, 3, 4, 5. Right here. So now I'm going to do y. When y is negative 1, x is what? 1/4. Right? That's okay. And then I move to the left 5. 1, 2, 3, 4, 5, and down 2. All right, so then when y is 0, wait, what did I do? Did I do that right? Oh, I did. I went down 2. I look like I went down too much. When y is 0, x is 1. Then I move to the left 5. 1, 2, 3, 4, 5, and down 2. When y is 1, x is what? 4. 1, 2, 3, 4. Then I move to the left 5 and down 2. Okay, so those are my 3 anchor points that are found their new homes. But I don't have an x-intercept graph, so I need to figure out what it is in case it's something that I can graph. So in order to find my x-intercept, what do I do? Set y equal to 0. So I'm going to have 0 equals log base 4 of x plus 5 minus 2. And then I need to be able to solve my log equation, right? So what would I do first? Probably not first, though. What should I do first? Add the 2. So I get 2 equals log base 4 of x plus 5. Can I subtract 5 from both sides? No. Can I divide by x plus 5? No. But what can I do? Exponential form. Good. So you have to isolate the log before you can put it in an exponential form. So I'd have 4 to the 2nd power equals x plus 5. So 16 equals x plus 5. X equals 11. So when you're asked what is your y or what is your x-intercept, it would be 11, 0 because that's going to be a blank you have to fill in. But it does go off your graph by 1, but since it just goes off by 1, not a bad idea to go ahead and plot it because it can help you with your shape. And it's going to look like this. What questions do you have? There's not an asymptote there that we're not seeing, no. No, because as x approaches infinity, what does f of x approach? Infinity, just not as quickly as it does on some other graphs. Okay, but it's going to keep going. All right, y'all do try number 7 on your own. Oh, this is a 1/2. Yeah, the blank disappeared. I don't know why. That was a big problem for me last year. I thought I've caught most of those, but I didn't catch it. Okay, so that's what it should look like in general. What questions do you have? Anything? Good. This should be a smoother curve. Let me just point that out. I was just trying to hit that point. Like it shouldn't go, drop off, but yeah, whatever. I'm not redrawing it. If I try and redraw it, it'll just be worse. Well, did you get 1/2 to the negative 3 power?
I got 1/2 to the 3rd power.
Okay, but when this is plus 3 right here, did you subtract 3 from both sides? So then you should have had 1/2 to the negative 3 power. You probably just rewrote it wrong when you rewrote your exponential. Because if you subtract 3 from both sides, you get a negative 3 here. So you get 1/2 to the negative 3 power equals negative x.
So 1/2.
The base to this power equals negative x. All right, we good? Yes. It'll click with him in just a second. All right, let's look at number 8. To rewrite our parent function as an exponential, this is going to be e to the y power equals x. This 3 does what? Good. Vertical stretch by 3. And then that 1 means I do what? Down 1. Is there anything that affects my asymptote? No. So it is still here at x equals 0. All right. So then when y is negative 1, what is x? 0.36. Vertical stretch by 3. My y value is negative 1, so it becomes negative 3. And then I go down 1. So I'm about right there. When y is 0, x is 1. Vertical stretch by 3, well, 0 times 3 is 0, and then I go down 1. When y is 1, x is what? About 2.7. Vertical stretch by 3, my y value is 1, so my y value becomes 3, and then I go down 1. End up right there. All right, so did I graph my x-intercept? No. So I got to go see what's happening with that. So I'm going to have 0 equals 3 times the natural log of x minus 1. So I'll add 1 to both sides to get 3 times the natural log of x. Before I put it in exponential form, what do I have to do?
Put the 3 over there. Yeah, x to the 3rd.
I could make it x to the 3rd. That works. What else could I do? I could divide by 3. That's actually going to make it a little bit easier. So get 1/3 equals the natural log of x. Now I can put it in an exponential form. So I'm going to have e to the 1/3 power equals x. Now, do you know what e to the 1/3 power is? No. No, it is absolutely not 2.7 to the 1/3 power. It is e to the 1/3 power. Just like if you got square root of 17, it is square root of 17. So like that's the best we can do. That's what we would write as our x-intercept. And so I'm not going to graph it on there. I'm going to go, I'm going to hit it, hopefully close to it anyway with my bad graph, but looks like this. So I would say that e to the 1/3 power is a little bit more than 1, right? You can kind of estimate it at that point, but yeah. All right. What questions do you have? Well, good. You can graph these? Yes, sir. Yes, you can go to the rest.